In this video, we will use differential to approximate some measure errors. Let's try to see that from an example, right? So here we want to measure, we want to calculate the area of a disk, right? But we cannot measure that directly, so we measure the radius. If you measure the radius, you get errors, right? And so we want to see, due to the error of measuring the radius, what's the possible error, what's the maximum possible error for the area you calculated from the measured radius. So that's the problem, right? So let's try to write that down. So the radius of a circular disk is measured as 24 centimeter, right? So if you try to do that, we have a possible error, right? With maximum error in measurement of 0.2 centimeter, right? So no matter how accurate is your tape or ruler, there is always a possible error, right? And part A here is we want to use a differential, right? Differential to calculate the maximum error in the calculated area of the disk. After that, you want to do something else, right? You want to get what's the relative error, what's okay, what is the relative error? Just calculate the possible error, then divide it by the area you have calculated, right? You can change that to percentage. So that will be the percentage error, right? Let's see a solution. So basically, you want to calculate the area using the radius. So that's basically our function, right? It's quite clear. So solution. So given notation for here first, R here. Okay, let R here be the radius of the disk, and A here be the radius of, not radius, area of the disk, right? Clearly, we know that A here, because as a circle, right? Pi times R squared. Okay. Now we know that our value for AR is 24. Possible error on the measurement is 0.2, which means you might have a small change of R. So in this case, we are basically calculating when R is 24 centimeter, dr, small change, or you can call that delta R, equal to 0.2 centimeter. What's the differential? The differential will be the change of the area, which will be the error, right? So then let's try to do that. So we want to calculate when R is 24, dr is 0.2, what's the differential of the area, right? So by our definition of differential, we know that dA here is pi times 2 times R times dr, right? The derivative of this is pi times 2R. And so that's our dA, right? So when R is 24, dr is 0.2. So dA, the differential A, which is the possible error for A, is pi times 2 times 24 times 0.2. So that's basically centimeter cube. So that's a possible error if you try to use differential to estimate the error, right? Let's see, this is our A here. So this is the possible maximum error for in the calculated area, right? And B here, relative error, so will be the actual area is pi times 24 square. So the relative error is basically dA over A, right? So this is pi times 2 times 24 times 0.2 over pi times 24 square, right? So that's how do we evaluate this is relative error. So this will be 1 over 16, right? So that's one simple application of differential. We can use differential to estimate the maximum possible error in a measurement. When you measure the side length to calculate a volume or calculate an area, this is how do we use differential to estimate the maximum possible error.